Hello everyone, so in this video let's talk about the F problem from the Codeforces round 871. Problem name is Forever Winter. As you can see, a snowflake graph is generated with two integers x and y, both greater than 1 as follows. So as you can see, a snowflake is like this. Starts with one central vertex as you can see here. Now connect x new vertex on the central vertex. So you will connect, let's say for this x equal to 5. So you will connect 5 vertex to the central vertex and then connect y new vertices to each of these x vertex. So for every of these vertex that you have, let's say 5 vertices, you will again attach, let's say 3 to each of them. So this is a snowflake graph, which means that it has a central node or vertex. Then you have some x amount of vertex that is coming out of it, and for every x that is coming out of it, you again have y vertex that is coming out. Now you are given a snowflake graph, determine x and y. So you have to given a snowflake graph that is given to you, it determine the x and y that is happening. Now how you can do that? As you can see here is that because even though it is a graph, we don't actually need to traverse or find out any of that because we just only have to deal about how many nodes are there and how many connections are there. Because as you can see, you can just you are given edge. Let's say you are given in the input edges. By edges means that there is an edge between these two nodes, this node, and so on. So if there's an edge between these two nodes, which means that this node is connected to one, you can say this. If you somehow given edges, you can somehow make not an adjacency list, but a count list of each vertex, which means that for every vertex, how many edges it is connected to. So you can just somehow you will iterate over all the edges, and that let's say there's an edge between 5, 3, there's an edge between 1, 3, which means that there's an edge between 1 and 3, which means that 1 is connected to one of the complete edge. So you have to somehow get the count. So let's say there's an edge between 20 and 15, 6 and 15. So these are given to you. These are given some edges. Let's say there's an edge between 3 and 15, 15 and 8. So what you will do is that you will somehow make a you can say a vector. Okay, a vector of that will store out how many edges that are going that are connected to a particular vertex. So you will iterate over all the edges, and whenever you find, let's say there's an edge between 3 and 15, you will increment the count of 3 by 1 and 15 by 1. So in the end, you somehow get a list of how many edges a particular node is connected to or vertex connected to. Now, after that, what you can do is that you have to find it how many edges are there, or like so how many vertices are there among all the lists. So let's say you are given, let's say 21 is connected to one edge, 13 is connected to one edge, 1 is connected to one edge, 3 is connected to three edges, 15 is connected to five edges, and so on. So you're given some sort of an array like this. Okay, at every part, how many edges is it connected to? Now, among all of this array, you will find how many of the like vertices you have that is connected to only one edge. What I'm trying to say is that I have to somehow count out how many vertices that we have, that is here, that is only connected to one edge. How many vertices are connected to another edge? So you will make a map now. Iterate over this array now and just increment the count of whatever is the frequency that we have. Let's say this is connected to one edge. So we have find out one of the vertices that is only connected to one edge. So one incremented by one. Okay, let's say you have one of the vertex that is connected to three. So which means that I have somehow get a node that is connected to three. So increment that by three. So which means that somehow I'll get a map that will tell us how many vertices are there, which is connected with how many edges, the count of the vertex that we have. So what we'll actually try to get is that we will get that for, let's say, this example, what we'll get in the output, like the final thing that we have done after all this processing, we'll get that we have 15 vertices that is having one output edge, like one that edge. We have one, two, three, four, five. We have five vertices that has three edges, and we have one vertex that have five edges. So you will get this map as an output. Now, what is the actual final thing that you have to print out? You actually have to print out one of the thing is that this you don't have to print out. You have to print out the one that is having the number of vertices in X. That is the one, how many we have connected. So we have to first find out for the one, like for the one, you have to find out among this map that you are having, what is the number of edges that is connected to one. Find out for that. What is the number corresponding to one? That is equal to X. And whatever is the next number, because I have 15 edges, like 15 nodes, and we have five outgoing because there is one node that has five, let's say, edges. So which means that whatever is the one, like whatever one that we have that is five edges, that is the one, that is the central node. So it has five, which means that I will get five as X. And if I get five as X and we have total number of edges, or like not edges, number of vertices that has the maximum number, like whatever is the maximum of all of them, that because the outermost vertices will be the maximum or at most equal to the innermost, like this central one. Why? Because at if this is the most center vertex, then all the other vertex, as you can see, let's say we have five vertex like this. The other case can be the if this is x, let's say the number of vertexes that is connected to the central vertex is let's say x. So now the outer of this vertex, so which is connected to this, can be minimum of one. Let's say we have only have one as well. So if it is one also, the outer will be five. So the outer will be five or more than five. It cannot be less than five. So which means that as we go outer, it will be more. So whatever is the maximum among all the values will be the maximum number of leaves because that is connected to one. Whatever is connected to one, like how many are that is connected to one, which means that that is connected to one, which means that that is the outermost. That's the outermost. We'll take that, and whatever is this answer x divided by this, which means that 3, because this is 5, outermost is 15. So how many are there from every outer? That is 5 divided by 15, like 15 divided by 5, that is 3. That's the answer for 5 and 3. As you can see, the answer is 5 and 3. Okay. That's a complete thing that you have to do. Nothing much complicated itself. You just have to do that. Let's go into the code part now. So what we have done is that we have, because it is one indexing, not zero indexing, whenever we take an input, we'll first subtract it by one and then add the count. That is just used to find out how for every vertex, how many edges are there that is connected to at every vertex. So we'll first take the input of how many you can say vertex we have and how many edges that we have. Whatever number of vertex we have, we'll make a vector out of it so that we will find an incremental count of it. It will all the edges and count how many edges are connected to how many you can say vertices, increment the count. Then make a map, iterate over all the array and find out for like how many vertices are there of a certain type of frequencies. Increment that and find it in the map. Then find it out, as you can see, the one that is having the, you can say, like the one that is having one as the count of frequency. Find it out that, and the end that is the answer. And the answer next is what is the maximum among all of them divided that by the answer. Okay. That's a very logical code part for this particular problem. If you still have any doubts, you can mention in the comment box. Nothing much complicated itself. And I'll see you next one. Coding and bye.